Well, it's our first opportunity to evaluate a definite interval. Notice how we're looking at the Arrhenius-Sum parabola, which technically speaking is something we haven't been able to do so far with our high school level mathematics. And so this is something quite new. Now, it is the case that the function f in question is what you see in the integrand's position. But that x is a dummy variable. It says f of anything is 2 times that thing squared minus that thing plus 3. So now going back to my definition of a definite interval. Got the limit, and plays its game, got a Riemann sum. I hope I mentioned that phrase before. This within the limit is what I sometimes refer to as a Riemann sum. And I've got my f e divided a plus I delta x. Well, that gives me 2 times something squared, but the something is going to be my a plus I times delta x. Minus my x. Plus my 3. And all of that is being multiplied by my delta x. And I think at this stage of the game, prior to evaluating the limit, simply a game of 9th grade algebra. So allow me. Now that I've algebraically cleaned what's inside the limit as best I can, I will, number 1, distribute the limit process over the subtraction and addition operations. And number 2, I will replace what I have with the sum, which apparently I did not write. I'll make myself more room. Looks better. So I said distributed limit. Not quite yet. Let me first distribute the summation, because as we recall, the sum of sum is the sum of two sums. Subtraction is no different. Now, when I distribute the summation notation in, notice how it has to deal with the variable I, the index variable I. It has nothing to do with n, so I get to slip that out. And because of my limited board space, like I suggested earlier, the limit of sum or difference is the sum or the difference in individual limits. So in the end, I think I'm going to generate this. Will I have enough room? I just barely made it. However, next on my list, so notice that when it comes to the sum of the square of the first n natural numbers, you and I have already verified that that is indeed this algebraic expression in n. And I think likewise over here, sum of I, you and I have already found out that that's nothing more than this. And lastly, adding 18 to itself n times simply gives me 18n. Of course, the n's are going to cancel. And that being the case, let's evaluate these limits. Sorry, buddy, I'm just double checking my arithmetic. So, neglecting any arithmetic errors, looks to me like using my definite interval. I've computed the exact area beneath the graph of that parabola, at least as x ranges from my lower bound of integration to my upper bound of integration.